Students, this is lesson U4A06a. By the end of the lesson, you should be able to say, I can use properties of sides, angles, and diagonals to identify a trapezoid. So let's take a look. So what exactly is a trapezoid? We're continuing in our lesson series into the study of quadrilaterals. We've covered at this point four different kinds of quadrilaterals, parallelogram, a rectangle, a rhombus, and a square. We're going to look at another quadrilateral today, which is called a trapezoid. Now, how do we define what a trapezoid is? A trapezoid is actually defined as a quadrilateral with at least one pair of parallel sides. So if you have a quadrilateral with only one pair of parallel sides, and the other two sides don't necessarily have to be parallel, okay? They just don't have to be, okay? This is classified as a trapezoid. So if you think about this, okay, a trapezoid could actually be classified as a parallelogram because a parallelogram has two pairs of parallel sides. There's nothing that says, okay, that a trapezoid has to have two pairs of parallel sides. It just has to have at least one pair. Now, we can talk about a trapezoid as being an acute trapezoid versus an obtuse trapezoid. See if you can distinguish the differences between an acute versus an obtuse one. An acute trapezoid, okay, has the angles, all of the angles, has the base angles as angles that are less than 90 degrees, whereas the base angles over here, one of the base angles is going to be greater than 90. And then we can also classify a trapezoid as being a right trapezoid if one of the base angles happens to be a right angle. We can also classify trapezoids as being an isosceles trapezoid, where if we have two of the sides that are non-parallel are actually congruent, we classify that as being an isosceles trapezoid. Now, there are some properties associated with an isosceles trapezoid, and that is, well, if you do end up having the two non-parallel sides as being congruent, as it turns out, the diagonals will also be congruent. And this can actually be proven through the use of side and angle relationships. Okay, I encourage you to maybe walk through this on your own, but I'm not going to go through in this video just because I want to get to the heart of this problem, of this lesson, which is how to utilize some of these properties here. But again, I encourage you to think about why or how the diagonals in an isosceles trapezoid are in fact going to be congruent. Another fact about isosceles triangles is all base angles, not all base angles, base angles are going to be congruent. So these base angles over here are going to be congruent, and then the ones below are also going to be congruent. There's also another property associated with the with any trapezoid, and that is if we have a mid-segment, and the mid-segment is exactly like what it sounds like. It is a line drawn through the middle of the trapezoid. So in a trapezoid, if a mid-segment is drawn such that the two sides that are not parallel are bisected, the lengths of the mid-segment can easily be found by finding the average of base 1 and base 2. Base 1 being the top, the length of the top side, and the length of the bottom side. All right, let's see what we can do with the information that was just introduced. Let's take a look. All right, so here we have WXYZ is an isosceles trapezoid. Angle Y and Z are base angles. Find all angles of trapezoid XYZ. I want to encourage you to pause the video and try this on your own. See what you can do. See what you can make of this, and then we'll get back together. So hopefully you guys had some time to think about this. Angle Z is equal to 3n plus 30, and angle Y is equal to 5n. Notice this is an isosceles trapezoid, so therefore those angles, angle Y and angle Z, therefore must be congruent to one another. And if they're congruent to one another, we can then set them equal to one another. So because of this, I know that subtracting 5n and then subtracting 30 from both sides, I end up with n is equal to 15. And if n is equal to 15, I then will know what angle Y and angle Z are. Angle Y and angle Z will be 75 apiece. Since the angles up top, W and X, are also going to be congruent, I can then say angle W plus X plus Y plus Z will equal to 360, because this is a four-sided shape, of course, and a four-sided shape will have all the interior angles add up to 360. And since W and X are going to be the same, I can say W plus Y and Z will equal to 360. So, solving for angle W, I can then figure out that angle W is actually equal to 115, thereby making angle X also 115. Alright, WXYZ is an isosceles trapezoid. Angle Y and angle Z are base angles. Find the lengths of the diagonals if WY and XZ have the following relationships. Okay, so, and again, I encourage you to pause the video to try and figure this out on your own. Hopefully you guys had some time to do that. Now let's take a look at what we can do with this. Because this is an isosceles trapezoid, because you're given information about the diagonals, we can then equate the two expressions, which is describing what the length of the diagonals are. So we can say WY is equal to XZ, so therefore I can say 3n plus 20 is equal to 2n plus 30. Subtracting both sides by 2n, subtracting both sides by 20, I can then end up with n is equal to 10. And if n is equal to 10, I can then figure out what WY is, as well as XZ. They will equal to 50 units apiece. Alright, WXYZ is a trapezoid. Now there's no mention of whether or not this is an isosceles trapezoid or not. You're given points. A and B form the mid-segment of the trapezoid. If the length of WX and AB are given, find the length of ZY. Alright, so you're given the length of AB. You're told the length of WX. Now you're asked to find out what ZY is. Recall the mid-segment formula for trapezoids. The mid-segment is simply the average of the top length of base 1 and base 2. So we're just going to apply the formula verbatim, okay? So in other words, AB is our mid-segment, right? So we say we're going to call ZY X. We don't know what ZY is, so we're going to give it an unknown. So we're going to say AB is equal to WX plus ZY divided by 2. And we're just going to substitute everything in. 4 plus X divided by 2 is equal to 10. Cross multiply both sides. So I end up with 4 plus X is equal to 20. Subtract 4 from both sides. X will equal to 16. So in other words, ZY is equal to 16.